Good evening, everyone. How are you doing tonight?
Wonderful.
Very good. A little tired, perhaps, but otherwise in good spirits. Alive. So tonight we are going to cover chapter 13, and this chapter includes three topics that are not necessarily interrelatedly connected: inner classes, enumerations, and documentation. And what I would like to do is something different, which we haven't done yet. We're going to break down the class in three different parts. I will show you the lecture on enumerations, and we want to do an example together, which uses enumerations. We create the card suite program that you can use maybe to extend in the future if you want to create card games. And then that should take up more or less the first half of the class. Then we're going to split up the class in two groups. One of the groups is going to take on inner classes and then do an independent research without me presenting material. You can use the book or the web, the examples in the end of the book, and then you will, as a group, try to understand the material and then be ready to present it to the other half of the class. So let's say this will be this group, and we're going to move a couple more students, unless more students come to be. This will be the inner classes group. And so the other group is going to take the documentation, which is how to generate. Tom was just asking, I guess it's like a coincidence for you, Tom, how to generate documentation with the JavaDoc tool, which allows you to create HTML files similar to the way that the Oracle documentation is created. And so the other group is going to go over this, figure out what to do, how to present, and then there will be student presentations with some demos, and you share what you want. Okay? So that will be part 2 of the class, and if we have a little time, if the 1 p.m. class is an indication, we may still have a little bit of time left for free lab or open lab at the end of the class as well. So that's the plan. Okay, so enumerations. And you also feel free to use the lecture materials if you like. They also talk about enumerations and inner classes and the JavaDoc utility. All right, so what is an enumeration? Essentially, an enumeration is it's a group or a set of constants that we use, and it makes sense to use an enumeration in a case such as this one here, where you know that you have only so many possible options within a certain set. So, for example, if you're going to be creating shipping types, you can't have an infinite number, so it doesn't make sense to be a variable, but it's not just one either. Actually, it's 3, or it could be maybe prime time shipping and so forth, but just a certain set of possible values. And in this case, it's appropriate to use the enumeration, which is also, turns out, a Java type. So you can declare variables of the specific enumeration type. So here is the example. If we had to create a business object for the shipping costs, and then the shipping costs different based on different shipping times. So we have next day, second day, or ground, or maybe Amazon, who actually does use Java, is in one of their developments. I can imagine they might be using something like that for their shipping, except they would also add, let's say, prime. And I'm sure they have, I'm sure their logic is much richer than this one, but this is how you could realistically solve such a problem. And so how would you use the enumeration? Well, you can create a variable of type shipping type, and then you can call upon it with a dot syntax. So it's going to be shipping type dot, and then only one of these values that are listed here. Do you have a question?
So how is it? It looks like it's kind of similar to a method.
It's more similar to a class, because in fact, when we create one, we're going to see that you right-click. Well, that's not why it's similar to a class only, but it's created in the same way as a class and interface, and it's going to be just self-contained. In fact, an enumeration can contain methods in itself. So I think it's more closely related maybe to think about it as a class, if anything.
Can you import it and not have to use the Java notation?
Well, if it's in a package, you have to import the package. It is public, so it's going to follow the same rules, right? If it's a different package, you have to import the package. You look like the poster. Did anybody else tell you yesterday?
No.
You know what I'm talking about?
Yeah.
So is the point kind of that an enumeration, if you don't enter one of the choices, it spits you an error message, or is that?
Well, the point is that if you want one of the choices, they're organized in the same structure. So you can't have a shipping type dot anything else. So it constrains you to only use the available types within the enumeration.
Like a constant or something like that?
That's exactly right. It's like it is a constant. And further, the way that behind the scenes the enumeration is organized is they're ordinal, so it's 0, 1, and 2, so it corresponds to numbers. However, you can't call it as numbers. You actually have to use the enumeration name that is listed here. Here is another example how you might use enumeration. The shipping type, you can pass it as an argument to a method because it's a type. And so once you have done that, then you can use the different types of the enumeration to determine the business logic for the prices. So if the enum that was entered as an argument is shipping type UPS next, is going to cost $11 and so forth. Right? But you are constrained to work only within what you have defined inside the enumeration. And this is another example, a statement that calls the method. So if you wanted to call this method, what you do is you say double shipping amount is, the variable is equal to get shipping amount. And then, as I mentioned, you need to use the actual, spell out the name of the enumeration rather than say 1, even though behind the scenes it is true that 0, 1, 2, second day maps to 1, but you can't use it as such. And so we call this a type safe structure. Okay. There are a couple methods, there are more than 2 methods, but these are 2 of the methods that are available to you if you use the enumeration constant, and we can look up briefly the documentation at this point. Enum types. So in the documentation here, it tells us that it's a special data type that enables for a variable to be set to a number of predefined constants. The variable must be equal to one of the values. So Ted, as you were saying, you can't use anything else except what is defined here. And then another good example where you might want to use enum is, for example, if you want to have compass directions, there are only so many. Maybe you want to add southwest and whatever, but there are only so many. It's not free for all, so to speak. All right, or the days of the week. The example we're going to do is going to be to create a suite of cards, which there are only 4 suits. So that's a good use for enumeration.
They don't mention requirement.
Excuse me?
They're not mentioning it requires name and ordinal, optional.
Right, so the name and the ordinal are methods, so they'll be called as needed, they're not properties. So if you need to use them, you could, but they are methods. Here is one example how you might want to use an ordinal. If you know the sequence that you have used in your enumeration, and then if you wanted to use the numbers instead of the names, then you can say ordinal. So ordinal is going to map the values of the enumeration to the digits starting from 0, 1, 2, and however many there are with a 0-based index. So if ordinal of 0 is going to be next day, which is the first one, Ordinal of 1 maps to the second day, and ordinal of 2 to the third day. Okay?
You could
So-
put the UPS next day enumeration value inside that, the parentheses also, or the double quotes. No, inside the parentheses where it's got ordinal equals 0, could you just put UPS next day?
Yeah, so this is an alternative way, that's
Okay.
exactly right. We can do this 2 different ways. You can use the ordinal values, or you can use the, wait, let me show you this. Or you can do it like that. So it's just a matter of what makes sense, or what's your preference.
Yeah. Looks like it's kind of like creating an array for classes or something like that.
Yeah, I mean, an array, it's also related to an array because it's also index-based, so that's definitely related. Yeah. And you can import an enumeration with a static import. So you can say import static and then the name of the package, enumeration.star, and this is going to allow you to work with all of them. So if you have imported it as a static method, then you can say, for example, the ground is equal to UPS ground, and then shipping type of ground.toString. So toString, where do I have this example? I have it here somewhere. Oh, right here. In fact, how many of you are thinking about doing the extra credit? The extra credit actually asks you to use an enumeration, as you might have seen, and it also even asks you to declare toString as part of your enumeration. So in the homework, the enumeration is going to be, the homework is about creating a game of rock, paper, scissors, in case you haven't read it. And so you're asked to use an enumeration for rock, paper, scissors because it makes sense. The game can only have these 3 possible states. And so how do you declare toString with the enumeration? Well, you're going to use the toString to override it from, do you remember from where it comes, toString methods?
The base,
I'm sorry?
the object.
It comes from the object class. And you will override it, and this is the kind of work you need to do so that you can print your rock, paper, and scissor in a similar way. So you can make a note here that's available in the slides. And this also shows you that when you have an enumeration, you can put a method inside the enumeration. So this method is inside the enumeration. Okay, let's go ahead and code an example together. Our example is going to create suit card tester, so that when you give it a certain value, it's going to tell you to check against our design and object and the values of this object as we populate it, and tell us what is the suit and the face. So in other words, 10 of hearts or something like that. And the example that we're doing is the most, I guess, contained example to illustrate what we can do, but keep in mind that it's very extendable. So if you want to work with cards, I'll point out to you different ways that you can, starting from here, and expand it much further. And if any one of you does that, please, come and maybe share with the class if it's before the end of the class. Okay, so go ahead and start your Eclipse, and we'll do this together. Forgot my announcement for the evening. The poster is just out. Sorry to interrupt, but it's my talk actually. My talk on the AGI, Artificial General Intelligence, next Wednesday, and this is the poster. So hopefully you can come if you're interested in that topic. I know
Where will
some
it
of
be
you
held?
are. It's held in 3178, and I'll post an announcement as well. But forgot to mention in the beginning of the class. Okay, so magnifier. Okay, so we're going to create a new project. The name of the project will be Car Suit Tester. we're going to have a couple packages. We're going to have a package card. So we use the word card several times here, so make sure to pay attention to the casing, which casing is appropriate when. The package name should have lowercase casing, whereas when you're using it for the name of a class, it should have uppercase, right? So try to pay attention to those names. It will still work, but these are the conventions.
In the examples that he gives in the book, he always said for package name, it's always something something else.
Yeah.
Is that still doesn't quite make sense to me what that's supposed to be?
Oh, so
It's not
this
with
is
your domain.
this is the reverse domain notation that I've talked about it a couple of times. Essentially, I'm sorry.
You don't have to use that when you're defining package.
Oh, you don't have to use it, but if you, and here we don't need to use it because we're not going, our examples are not going anywhere. But if you are to share your examples professionally or post them publicly, then your package name should be unique because you don't want it to be confused with some other package from somebody else. And so a common practice is to use the domain name of your website because that's unique. So he only uses Murag, but it should be com.murag. Whatever your website name is, and then dot the name of the package. So we're just going to the name of the package. Otherwise, we would, if we're going live, we would add the entire reverse domain. So that's what that is. Okay, so finish this one. And then we also are going to add another package called UI. And let me just close a couple windows here. Okay. The card package is going to contain our card object and our suit enumeration. So we're doing the TA Cliff from the other class session was pointing out, you're probably noticing we're doing a lot of designing in this class. So you maybe you were hoping to do more hands-on. I mean, we are doing hands-on coding, but we're doing a lot of designing, and these design principles apply across different languages. So if you're going to learn any other object-oriented language, these principles will translate over or move over, I guess. So just we're doing a lot of designs of different programs at this point. Okay, so then we need to have a class card. We're going to model our card object. And the card will be in card. And this is not going to have any main in it. And so this is our new bit here. We're going to add the enumeration now. It's going to go in the card package. And it's just a matter of right click and say new enum right here. And then we give it the name. This enum is going to be called suit. And we go with the default settings. And here they are. And our UI is only going to have one class. And this will be the main class, or you can name it card suit app. I'll just name it main. And remember to add your main method here. So our project rather is set up. And I'm going to start with the enum since this is new. So you can see what was given to us from Eclipse. Or you can see, or let me know because it's. So you can see this. Can you see this? All right. So Eclipse gave us the package where the enum is, and then a stub public enum with the name of it. And so what we need to do now is give it the values. So if this is a suit of cards, tell me the values to add to it. Spades, and they will be capital case. So this is a constant. So spades, and what else? Hearts, clubs, and what else? Hearts. and diamonds, and that's it. So our enum is now defined. There can be only these 4 types of cards in a card deck, right? Now let's think about how we can model our card object. And again, I just want to point out that, at least in my view, it's really so much easier to do this kind of modeling and programming when you think about it in object-oriented terms, because we already are set up to think properly about it. We can start thinking what kind of properties or what kind of fields do we need, what kind of methods, and I think having the tool to think in object-oriented is very helpful. Otherwise, where would you even start to think about creating a card class or a card object, right? To make a program that uses cards. I mean, it's possible, of course, but this is a very helpful way, I think, to model objects with object-oriented. So now we know that what we need to figure out is what are the fields that go in a class of cards, and what might those be? What does a class of card have?
Value.
It's going to have values in the suit, so it has it's like a 10 of hearts and so forth. So we just need 2 fields, and the first one is going to be of type. So this will be the suit, and which type will it be?
No.
Good guess.
No.
I'm sorry?
No, it'd be suit.
It will be of the enumeration type suit, because now we have that. Otherwise, we might have had to use string. Suit, and we don't have to import anything because they're in the same package. And then you also said it has to have a value. And so I'm just going to name my value a number so I can be consistent with my program. What type should our number be, the number on the card? Right, because it's a whole number, so we can use an int. Okay, so these are our fields, and next we need to add our, we're going to use the default constructor, by the way, so this time we're not declaring one, and that means when we run the program, when the object is created, it's going to call. Do you remember what happens if we don't declare it? Will it work, and how will it work? Sorry, anyone? The default, yeah, but do you remember where it comes from? We're not writing it here, so how is that happening?
It's automatically produced by the compiler.
It will be automatically produced by the compiler, right? So that's what we're going to do now. And we're just going to add then the methods that we need. And last time we practiced adding them with a stub, but since there are only several of them and they use the suit, I'm just going to let us all hand type them. So we have the getter and setter for the suit and the number. So public suit get suit. It's going to return the suit. And set suit. And then we do the same with the number. So here, get and set methods, that's all there is here. And there is our card class. And just again, consider that if you're writing a card game, that's the information you need to have, right? You need to know which card was, what is the card value, and maybe you're going to have multiple cards, but you can see how this is a good starting point. Okay, and so then that's all we're going to do with the card class, and we just need to, oh, sorry, are we ready to move on? Are you guys, did you finish? Okay, then we're going to move to the main in the UI package. Now this is a different package, so we're going to need to import card.card, and is everyone comfortable what these mean on line 3 and 4? The package name and then the class inside the package. And alternatively, as I think I said last time as well, we could just say import card.asterisk, and that would work as well.
I'm wondering, can you just import card, the package?
Yeah, so you could do that. You have to say .asterisk though. Yes, because it needs to know which of the package of the classes inside the package do you want to import. But it's better to be explicit so that if somebody's reading your code, they know what you're using from the package. In this case, it's not much. But if we write it like that, the code becomes more scalable. Okay, so now let's figure out how we're going to do our test. And again, we're going to just hard code the value of the suit and the number, because that's our first iteration of the program, and that's what we're going to do today. But just keep in mind that you can extend it to take the number from the user or and so forth. So keep that in mind. So we're going to say in the main class, in the main method, welcome to the you know, you're tired when you can't see the opening parent on the keyboard, right? Welcome to the suit tester. So to test our class, we need to create an instance of it, and we need to set set a test value for the suit and for the number. So creating the class is going to be card is equal to new card. So instantiate object, a card object. And now we're going to set our test values. So card dot set suit, and now we need to give it a value. It's telling us here the type that it wants is a type suit. So we're going to say suit dot, and then just pick one. How about spades? And then card dot set number. So the valid numbers for a card deck are from what to what? From 1 to 10, and then also we have the king and so forth. So 13.
No, Is 1 equivalent to 12?
Yeah, so 12 would be, 13 would be greater than what is available. So we can give it one of these numbers. We can start with 1, and then later you can change them and play with different numbers. But 1 is definitely one of the numbers, and it was funny because it turns out that we are going to be testing for ace of spades. So I don't know if any of you are like into Motorhead, and it turns out it's a Motorhead song, which is pretty funny. So let's test for that. Okay. So this is our test setup, and now we're going to test it with calling a method which is going to be display card, and we haven't coded it yet. It's going to give you an error. So I'm putting it in the main. So this is where I'm saying that's how I'm going to be displaying my cards, but we haven't coded it yet. And we can put it in a different file, but since this is a pretty small file as it is, we can just add another method to the main class as long as it's outside of the main method, right? So we can have multiple methods here. So as long as you're outside of the main method, we can start coding right here. So this would be a public static void display card, and it's going to take a card. Now our error goes away in the main. And now we need to add our logic for testing for the different numbers in the card deck. So this will be a lot of if then else's, and you could do a switch with the enumeration as well, but we're going to use if then else. So I'm going to say if card.getNumber is equal to 1, then what am I going to display? Well, that's the ace. So I'm going to say ace. And again, we're just printing them in this version, but we could use the same logic and then replace the printing with maybe getting 2 different numbers and then comparing them and generating a game like blackjack or some other kind of card game. All right, so if it's 1, it's ace. Else if it's 11, so I'll show you why we skipped through 11. If it's 11, then what is going to be the card face value? Okay. And I'm using print instead of print line, by the way, because we're going to be concatenating it with some additional text. Okay. So just want to check in to see if everyone is following okay what we're doing here. All right. So 11 is Jack. Else if it's 12, it will be the Queen. And else if the number is 13, it will be the King, right? So far so good. Let's see here. So now we have to figure out 2 things. We have to figure out what if the number is greater than 13, and also we have to figure out how to print the numbers between 2 through 10, right? So this is our next job, and I think this is a pretty nice way of doing it. So we're going to check the following. Next, we're going to check if the card number is greater than 13. Then we're going to say let's say we're going to say a question mark. So if it's greater than 13, there is no such card. And then we have an else statement. So which case is left here, logically speaking?
Greater than or less than.
And that's exactly what we want, right? So the else turns out is going to cover exactly the cases we want. And to print them, what can we do to print them?
We can parse it, or not parse it, format it, we can do number format, we can do two string.
The system out print get number, right?
We could actually just do get number because they're ints.
Okay.
So we can print it directly. This one is easier than it looks. So we could say in the else, we're not testing for any condition, but in any other case, because of the way we built our condition, this is going to catch exactly the numbers we want from 2 through 10, including 10. We can say card.getNumber, and this will print the number. And this is getting the I guess they called phase values of the cards is what phase cards. Get the phase cards. Okay. So we're halfway there. We now need to use the enum to test the suit, and we're going to add a system out print, and then use the word off because that's it's going to be, for example, king of spades and so forth. So that's why we have this off here. Okay, so let's figure out how we can test for the suit. And so we have a card.getSuit. So we get the suit from the class. And if it's equal to suit.spades, then we're going to print spades. And then we continue the same way to test with the other 3 possible values of the suit from the enumeration. Cards. And of course, they're showing up as you can just, when you use the dot notation, they show up here in your helper code, autocomplete. Because we have so many if then else, it's important to be disciplined about the way you place your brackets, or it's going to get confusing. And we're still doing print rather than print line, by the way. So print cards. Pubs.
Can you just do an else and say system out print diamonds rather than a pet suit for the fourth one?
Yeah, but what if the user entered XYZ? That would still be counted under else. Do you know what I mean?
Yep.
Right. So you could, but it might not be accurate. If the user entered something else, it still print diamonds. But if you say else if, then it's only going to print diamonds if it is diamonds. All right, and then finally, I can spell diamonds apparently. And then outside of the loop, we're going to add an exclamation mark. And we're done. I'll let you finish and then, actually I like to test before you finish typing in case there is something.
Probably shouldn't print the exclamation point on a new line.
Well, it's going to add to the, so let me print it so I can show you. It will be just right because all the other prints are print, so they add on to the existing line. And then you add the exclamation mark, and then, I mean, you could say, I guess, print as well, because we don't have anything else afterwards. But
Because I put print, but I thought that print line would print the exclamation point on the line. Why is it not?
no, it depends on what's previously here. In other words, if you have, this is the spades, if you have print line here, for example, that's where this is coming from. So now it should, so the print line, the print was making it so that the exclamation mark goes on the same line. Okay, so this appears to work. So go ahead and finish it and make sure it works for you. And then we can talk about it if you have any questions. And it should give you the right face and suit cards.
I'm getting more.
We'll look at the first one. So there's a typo here, I see immediately, so I'll change that. But that's not the, I think we should look at the, so here it doesn't work, return suit. No, that's fine. Oh, because, what is their message? Could you show me their message? Oh, okay, so this has to be a lowercase. You're trying to return the type, but it's actually, you said the variable name in the return, which happens to be the same. Here is uppercase. So when you're defining the methods, it should be the uppercase, all right? And then type Oh, okay, so this one is returning, this one actually is not returning anything. Can you take a look and see why this might be a problem? So this method doesn't return anything. And so you have a void here, which is correct. But then why did you put this here? What do you think this was doing? So this was indicating a return type, but there isn't one. Okay. Just looking for any questions? It's pretty easy because we did a great job designing, so it's really easy to understand, right? This is how I did it. I mean, can you even think, how would you go about if I said design, call this program, but don't use object-oriented, how would you go about it? If the requirement
Be
was don't
gigantic
use
if then else,
a bunch of if then else's?
a whole bunch.
Right.
Like 13 times 4.
If we could dig up our go-to state.
What happened here? Okay, so you've been using print line instead of print things. Okay. So if you're getting this, what it means is that you're using print line, and that's what exactly what you're seeing. Print line is going to take up the entire line, so you need to make this into print. What were you saying?
Well, I was saying, you could also probably do it with a two-dimensional array.
You could do it together, right? That's true. But I think it will be harder, in my opinion. Any other questions or comments? Okay. Well, and that's how you use enumerations. Oh, I should mention that as far as the extending the program, some student asked in the other class that there was a good question. If you wanted to randomize the number here, then you could do that by using the random class nextInt method that we used for the guessing game. And what you have to think about is, remember that you pass the nextInt, or getInt rather, it's getInt, sorry. What is going to be the argument you pass to getInt to get this to work? It's a random number, but what about it?
With the top upper limit.
The upper limit has to be
3.
3 because it's 0, 1, 2, 3. So it only can have 4 values, right? But you could do something like that. You could generate a random number, which is an integer between 0 and 4 or 0 and 3, and then use it as a random seed here. Actually, sorry, this is not 4. I was thinking about the previous. This can have more than 4 values. It can have 13.
Oh, you're talking about the
card
number,
game.
not the suit.
Yeah, so you have to have maybe 2 different ones. One random for the number itself, which can have values up to 13, and then one for the suit, which can only have 0 to 3. And you can do something like that. And then this would be the side of the AI, so to speak, that plays. So you'd use the random to play against somebody else, and they can put their own number and so forth. Or maybe to generate 2 hands and can go on from there. Okay, so I guess we can take a little bit of an early break, 5 minutes, and then when we come back, I'll figure out our groups and go about the rest of the evening and learning about dinner classes and Java Doc.